On a set of axes, show the set of values that satisfy this inequality. Now, of course, the first thing that you need to do is to determine whether you're going to have a dotted line or a solid line. So by inspecting these guys here, you can clearly see that this will be dotted line, and this will be a solid line. Good. Once you've determined that, you go straight away to step 1. And in step 1, we want to draw the line showing x is equals to -6 and y is equals to -1. So draw lines showing x is equals to -6 and y is equals to -1. Now keep in mind, one of them will be a solid line, another one will be a dotted line. So let's go ahead and graph this, guys. So x is equals to -6, just a vertical line. Pass it through -6, so x is equals to -6. The next one, which happens to be the dotted line, is y is equals to -1. So y is equals to -1. Now this is supposed to be a dotted line, so we end up with a dotted line. Okay, this is y is equals to -1. And step 2, shed the unwanted region. Shed the unwanted region. Actually, I'll write step 2 here. So we are going to share the unwanted region. Let's start with y is less than -1, which means if y is less than -1, everything above that line is unwanted. That's all gone because the region that is required is below that line. Okay, and then x is less than or equal to -6, which means everything to the right is unwanted. So everything to the right is unwanted. So basically, our required region is what's left here. Example 5. On a set of axes, show the set of values that satisfy this inequality. And of course, the first step is this guy. You need to decide if it's going to be a solid line or a dotted line. Of course, this will be a solid line because all the points on that line are inclusive. Step 1, draw the line showing y is equal to x plus 3. So draw the line showing y is equals to x plus 3. You may need to just draw a table, just a small table, because to draw a straight line you need at least 2 points. So I'll just include 3 points because 2 are enough, but at least 3 will be good. So when x is 0, just by inspecting this function. When x is 0, y will be equal to 3. When x is 1, y will be equal to 4. When x is 2, um, y will be equal to 5. And if we come and plot it on the whatever, so when x is 0, y is 3, is somewhere there. When x is 1, y is 4, so somewhere there. 2 is somewhere there. And then we can go ahead and draw our line passing through these points. And this line goes from positive infinity to negative infinity. So it should cover the whole page. Okay. Now remember it's a solid line, so that's all sorted. And it's y is equals to x plus 3. Step 2, we are going to choose test points and substitute them into the inequality. So choose test points and substitute them into the inequality. So what that means is I have to select 2 points here. I'll select negative 6, 7. So that will be my A, negative 6, 7. Doesn't matter which point you choose. You can choose any. B, I'll choose 5, 4. Good. So I need to test these points, which means I need to plug them into this inequality. So point A, remember that's x, that's y, that's x, that's y. You can always label them because some students, they do get confused for the x and y coordinate. Just label them. You won't be deducted marks because that's part of your working. Okay, so if we plug, so let's start with point A. Our y is 7. So 7 is less than or equal to x, which is negative 6 plus 3. What that means is 7 is less than or equal to negative 3. Well, that doesn't make sense at all. So, of course, that is the unwanted region. Anyway, just to be sure, let's check point B. You don't have to, but purposes of understanding, I'll just plug the point B coordinates into the inequality so that you can see that that's the required region. So we'll have 4 is less than or equal to 5 plus 3. So 4 is less than or equal to 8. Of course, 4 is less than 8. So that means that is the required region, which means we are going to shed this side because this is the unwanted region. Okay, and that's it. Example 6. On a set of axes, show the set of values that satisfy this inequality. So here we'll have at least 3 steps. Step 1 will be to rearrange the equation so that y is on the left. So rearrange the equation. So that y is on the left. So that means my equation will be if I move that to the other side, I'll end up with y is less than 4 minus 2x, because if 2x moves to the other side, you end up with negative 2x. And just taking you back to what I was meant to say in the beginning, what we'll end up with here is dotted line. Just keep that in mind. Anyway, step 2, we need to graph the line showing y is equals to 4 minus 2x. So draw the line y is equals to 4 minus 2x, which means simple table, we just need 3 points. So x, y, 3 points are enough. So when x is equals to 0 here, y will be equal to 4. When x is equals to 1, y will be equal to 2. When x is equals to 2, y will be equal to 0, because you'll have 4 minus 4, which is 0. And then, so if we plot these points, remember we have a dotted line, just keep that in mind. When x is 0, y is 4. When x is 1, y is 2, which is there. When x2, y is 0, and that's it. So, draw a line passing through these points. I know it's a dotted line, so I'll change that in a bit. Just need to draw this line. Now remember, this line goes from positive infinity to negative infinity. And always remember to use a ruler when you're drawing these lines. Okay, so that's what I have. So this is y is equal to 4 minus 2x. So, step 3. We need test points. So step 3, choose test points. Um, Now we are going to substitute them into the inequality. So back to our graph, we need test points on either side of this line. So I'll choose negative 6, 5, which is here. Doesn't matter which point you choose. You can choose any point and try it as well. And I'll choose 5, 4. So one of these points is on the required region, another one is on the unwanted region. And that's our goal. We want to determine which one is in the required region and which one is not. So let's start with point A. So I'm going to use the original inequality, which is 2x plus y is less than 4. Okay. So the first one, point A, remember x is negative 6. For point A, x is negative 6 and y is 5. So I'll have okay. So point A, I'll have 2 multiplied by negative 6 plus 5 is less than 4. So 2 multiplied by uh, negative 6 plus 5 is because x, remember for point A, x is negative 6 and y is 5. So I've just plugged them into this inequality here. Okay? Anyway, carrying on, what you're going to have here is negative 12 plus 5 is less than 4, which means that negative 7 is less than 4, which makes sense because negative 7 is less than 4. All right, how about point B? So here I'll try and plug in point B, see what happens. So for point B, which is 5, 4, I'll have 2 multiplied by 5 plus 4 is less than 4, which means I'll end up with 10 plus 4 is less than 4, 14 is less than 4, which does not make sense. So meaning that point A here is on the required region and point B is not, is in the unwanted region. And remember, in inequalities, we share the unwanted region, which means that is the part that you're going to shed.